All right, boys and girls, here we are with lesson 2 of our second unit of science. So if you'll recall last time we talked about different materials and the different properties of materials and how depending on what it is we're trying to make, we might want to use different materials for it. Today we're going to still talk about um, building structures in some sense, but we're not going to talk about the materials, we're going to talk about components. So what is a structural component? A component is a part of a structure or a piece of a structure, right? So for example, let's say I have a desk in front of me, right? It has some components would be the top, the legs, um, the metal piece at the front, right? Or anything else that is a piece of a structure. Okay, for a door, you would have the door itself, the hinges, the handle, the lock, all of these things. Okay? All right. So, most structures are made up of many different components that have to be joined together. The places at which components are joined are called joints, right? You've probably heard of this in terms of like joints in your body, like at your knees or at your shoulders, right? Similarly, a joint is just any point where two things are attached. So the joint in your knee is where the lower part of your leg, your calf, is attached to your thigh, the upper part of your leg, or where your shoulder is attached to your chest. That would be another joint. Your arm, I guess, attached to your chest. Okay? So what's friction? Let's talk about friction. Friction, whoops, sorry. Friction is a force. It's a type of force that you get when you rub things together. All right? So take your hands um, flat, put them together, and rub them back and forth like you would if you were trying to keep warm.
Miss Billard to the front. Miss Billard to the front, please.
And that's an announcement for Miss Billard. All right. So I don't know if you can actually hear if this is picking up in the microphone or not, but I'm rubbing my hands together very quickly, like you would over a fire trying to keep warm, right? Almost like you're praying, like your hands slapped together, back and forth, and you'll feel it getting hot, right? That comes from friction. All right, friction is the force that occurs when you have any two objects rubbing against each other. All right, it usually makes heat. You get friction burns if you slide on a carpet with bare skin. You get those burns, that's from friction. Okay? So there are some joints that rely on friction. All right? They rely on two objects touching each other and kind of, whoa, there goes my voice, touching each other or rubbing against one another. An example is a nail through wood, or a screw, or staples, or what's another good one? Shoelaces, right? Anytime where you have a joint, two things attached together, um, two things or two things in contact with one another that are attaching two components of a structure, right? If your table is held together with nails, the joint is the nail. Okay? All right. There's some more examples in the note too, if you look at that. So there are other joints that rely on bonding. So this is when you have two components joined by a common material. Now what does that mean? Well, I'll give an example. Glue, right? If you glue two things together, that means you have part one and part two, and they are glued together. They're attached with some other thing in between, right? Glue is a good one. Tape is another common one. Melted metal, right? You'll often see that in welding. Glue, tape, melted metal. What else have you got? The sticky tack, right? Anything like that where you've got a foreign material or a different material stuck between two components that you want to stick together. Okay? Yes, this too. Okay, there are two different types of joints. Okay, we have fixed joints. Those are joints which don't move. They're fixed in place. All right? Flexible joints are ones that can move. Now, flexible joints you see everywhere. Like your shoulder. You wouldn't be able to move your shoulder if it was fixed. It would just be stuck. You wouldn't be able to move your arm. Hinges on a door are an example of a flexible joint. If they were fixed, you wouldn't be able to open the door, right? Anything where the joint is moving is flexible. Anything where the joint is stuck, like say where the leg of a desk is attached to the rest of it, you wouldn't want that to be flexible because if it moved and you leaned on it, your desk would collapse, right? Or on a shelf, right? Where the shelf is attached to the wall. You don't really want that to be flexible either because then your shelf will bend and everything will fall off onto the floor. Does this make sense? If it doesn't, shoot me a message. Okay, that's tomorrow's. Okay, so your task for today is to do this sheet called Joining Structural Components. So your first one, I want you to tell me if it's held together by friction or bonding. So is it just things things in contact with one another, like nails or screws or staples or anything like that? Or is it by bonding, so glue or tape or anything where you're sticking two materials together with some, or two components, pardon me, together with some material in between. So what holds pages in a paperback book? Right? Is it glue? Is it tape? Is it a nail? You tell me. Frame of a desk. What holds the frame of a desk together? Right? A stone wall, knobs on a cabinet door, hinges on a door, cardboard box, button, wheel held onto a rim like on a car, gift wrap on a present, piece of Lego, and pipes under a kitchen sink. How are these things held together? Your answer should be either friction or bonding, right? Nothing else should appear here. It should be one of these two. Okay, the second question. Why is it important to design joints to last for a long time? Right? If the joint doesn't last very long, if the hinges on your door did not last for a long time, what would happen? Right? Think about that. Why is it important for joints to last for a long time? What would happen if they didn't last for a long time? Would that be good or bad? Right? This one, you're going to fill out the table. So we've got a desk, a coffee mug, and a door. Tell me, is it a solid frame or shell? What's the function? So what is it for? What do you use a desk for? What do you use a coffee mug for? What do you use a door for? Materials. So give me some materials that it might be made out of. And tell me what joints are there. So give me one example of where joints in a desk are, or on a coffee mug, or on a door. And the last question, again, it's either going to be flexible or fixed. Tell me if the joint given can move, so is it flexible, or does it not move? Is it fixed? So where two blades on a pair of scissors, pardon me, are fastened, is that flexible or fixed? Well, you tell me. How about the point where a blade and the handle of a knife are attached? The frame of your desk, door hinge. I gave this example earlier. Everybody should get this one. Your elbow. Is your elbow able to move or not? The frame of your spool. Should those joints be movable or not? Screw cap on a bottle. Point where pages are fastened to the spine of a book. Where the leg is attached to a tabletop. Hands on a clock. The hinge on a pencible, that's not a word. Hinge on a pencil box lid. And point where the handle is joined to a pot, like a cooking pot. Okay? All right, that should be all there is to it. If you need any help, you know where to get a hold of me. Until then, have a good day and stay safe.